Look at your hand right now. Really look at it. The skin on the back of it is thinner than it was 10 years ago. Softer, a little looser, but the bone underneath hasn't changed at all. It's the same shape it was when you were 25. Your skeleton is patient, your skin is not, and that difference is stranger than it sounds. Because both are made of you. Both are living tissue. Both are fed by the same blood, built from the same proteins, governed by the same genes. So why does one wrinkle, sag, and spot decades before the other even begins to change? The answer isn't really about age. It's about exposure. Your bones live inside you, sealed away from the world, wrapped in muscle and fat and skin like a vault. Your skin lives on the outside, facing sunlight, air, friction, and time, every single day, with nothing protecting it but itself. It is your only organ that touches the outside world directly, and that job comes at a cost. Here's where it gets interesting. Skin cells at the surface, the ones you see when you look in the mirror, are already dead. They're flattened, hardened cells called keratinocytes, and they get replaced constantly. In your 20s, your body swaps out that entire outer layer roughly every 28 days. By the time you're in your 50s, that cycle can stretch to 45 days or longer. Your skin isn't just aging, it's slowing down its own repair schedule. Compare that to bone. Bone tissue is also constantly replaced through a process called remodeling, but it happens on a completely different timeline and through a completely different mechanism. Specialized cells called osteoclasts break down old bone, while osteoblasts build new bone in its place. This cycle can take months, sometimes years, for a single section of bone to fully turn over. Slower, yes, but also shielded. Bone isn't fighting ultraviolet radiation. It isn't fighting pollution. It isn't fighting gravity pulling on exposed tissue hour after hour. Skin is losing a war that bone never has to fight. The biologist Leonard Hayflick discovered something in the 1960s that changed how scientists understood aging altogether. He found that human cells can only divide a limited number of times before they stop completely, entering a kind of biological retirement called senescence. This became known as the Hayflick limit. Every time a skin cell divides to repair sun damage, or heal a scrape, or simply replace itself on schedule, it uses up part of that limited supply. Skin cells divide constantly, exposed and overworked. Bone cells divide far less often, tucked safely inside. One tissue is spending its biological currency every day. The other is saving it. But cell division is only part of the story. The real damage happens underneath, in a protein most people have heard of but few actually understand. Collagen. Collagen is the scaffolding of your skin. It's a long, rope-like protein that keeps tissue firm, elastic, and smooth. In your 20s, your skin produces collagen faster than it breaks down. By your 30s, that balance flips. Dermatologist Barbara Gilchrist, whose research helped define how sunlight ages skin at a cellular level, showed that ultraviolet exposure triggers enzymes called matrix metalloproteinases. These enzymes chew through collagen fibers like scissors, cutting the scaffolding apart faster than your body can rebuild it. Sunlight isn't just tanning your skin, it's dismantling its structure, one exposed afternoon at a time. Researcher Gary Fisher, working at the University of Michigan, spent years mapping exactly how this breakdown happens. His studies showed that even short bursts of UV exposure can trigger collagen-destroying enzymes within hours, long before any visible sunburn appears. The damage starts silently, you won't see it for years. But your skin is keeping score the entire time. Now think about what your bones are doing during all of this. Nothing dramatic, no sun exposure, no enzymatic assault, just slow, steady, sheltered maintenance, one quiet remodeling cycle after another. Why did your body design it this way? Why let your outermost layer take the beating while your skeleton stays protected? Because your skin was never meant to last forever. It was meant to be replaceable. Sacrificial, almost. For most of human history, skin took the damage so that what was underneath, muscle, organs, bone, could survive. A scraped knee heals. A sunburned shoulder peels and renews. Skin evolved as a barrier that could take a hit and regenerate quickly, not as a structure built for permanence. Bone, on the other hand, had to last. It holds you upright. It protects your organs. If bone degraded as fast as skin, you wouldn't survive childhood, let alone old age. There's a deeper twist here too. Sugar plays a role scientists didn't fully understand until relatively recently. When sugar molecules in your bloodstream attach to collagen fibers, they create rigid, tangled structures called advanced glycation end products. This process, called glycation, stiffens collagen and makes it more brittle over time. Skin, sitting close to the surface with a rich blood supply, absorbs this effect visibly. It's part of why fine lines deepen and skin loses its bounce. Bone experiences glycation too, but the effect takes decades longer to show, buried deep beneath everything else. So skin ages fast because it's exposed, because it divides constantly, because it takes ultraviolet damage directly, and because it was built to protect what's underneath, not to outlast it. Bone ages slowly because it's shielded, because it divides less often, and because its entire evolutionary purpose was durability. Here's the part that should change how you think about your own reflection. Every wrinkle you see isn't a sign of failure. It's a receipt, evidence that your skin did exactly what it was designed to do, absorb decades of exposure so the rest of you could keep functioning underneath. You are not aging unevenly by accident. You are aging exactly the way biology intended. Your skin was built to take the hit. Your bones were built to endure. So look at your hand again. The skin has changed, the bone hasn't, and now you know why that difference was never a flaw. It was the plan all along.